Hey there guys, Paul here from theengineeringmindset.com. In this video we are going to be looking at the VRF HVAC system basics. Now this follows a series on VRF units and they progressively get more and more technical, so you should start here to build your base knowledge of the subject before moving on to these more advanced videos. Now VRF stands for Variable Refrigerant Flow. This is also sometimes referred to as VRV, meaning Variable Refrigerant Volume. Both terms essentially mean exactly the same thing. It pretty much just varies by manufacturer on the title which they use, but both acronyms relate to this slightly complex version of a HVAC refrigeration system for buildings. Now the reason these units are called variable refrigerant is because the unit is able to modulate the amount of refrigerant that flows through the system. It uses a variable frequency drive to alter the speed of the scroll compressor. This is very energy efficient as the speed is reduced to match the exact requirement. Now normal cheaper compressors, as you can see here on the left, these will just switch on off to try and maintain the load. As a result, you'll see it's constantly under and over swinging or shooting, giving pretty poor control, and also obviously a much higher energy consumption. Whereas with the speed control compressor, you get a much tighter control, and that results in much lower energy consumption operating throughout. So the inverters also provide soft starts whenever the VRF system comes online, and this means you don't suffer from high inrush currents, which can damage your electrical distribution throughout the building and also result in high penalty fines from your electrical distribution supplier. So the reason VRF units were designed is because traditional split AC unit systems can only provide cooling to a single zone, and that zone can only be heated or cooled. As you can see on the screen here, so we've got a building here and we've got our outdoor condenser unit with our evaporator inside of the cassette, and this unit can only provide heating or cooling. Now the next advance from that was the multi-split unit, as you can see here on the screen. And this did allow multiple zones to be fed from one condenser unit, although there's a lot of pipework has to be installed, so each zone is individually piped. So it's quite a lot more effort to install, and these systems are usually way oversized and they do not provide very good or very close control. VRF units, on the other hand, these can supply multiple zones, and we're going to see how the different versions can also provide different thermal comforts and also how they save a lot of energy in the buildings. So there are three main types of VRF systems. The first one, and the most simplest version of this, is the cooling only VRF unit, where all units can only provide cooling. The second type of VRF unit is the heat pump, and this is where all the units can, again, are all for different zones, but they can only provide heating or cooling. They cannot provide both. Well, simultaneously at least anyway. You have to change the system over to provide heating or cooling, and all of them together, all these units, will provide heating or cooling at the same. And then the third option we've got is the heat recovery VRF system, and this is where all the units, this is much more advanced and much more complex, and we'll see these in later videos, but in this scenario all the units within the building can all be designated as separate zones, and they can be heated and cooled simultaneously. Now in all these cases, each zone, as you can see here, has its own controller, and that can control the thermal temperature of its individual zone without affecting the other room. So this unit can be switched off, and this one can be switched off, and this could be on, and this one could be off, and the system will continue to work without being affected by the other units. And because VRF units need to reject heat and also absorb heat, they need to be placed outdoors, so you'll usually find them outside on the ground level, or you might find them like this up on the roof. These are the two most common locations. Now you'll usually find the VRF units off in office blocks, shops, warehouses, apartments, hotels, and they're becoming more and more popular to be installed by the contractors. Now the reason they're becoming more and more popular is because they are very energy efficient, and this means lower operating costs, and they also provide very good thermal control. As some of these units they can provide heating and cooling, then they save precious space within a building, so you might not need an additional boiler or chiller, and obviously it takes up a lot less room compared to multiple split units or a multi-unit. They are, however, quite expensive to install, and that's because of all the controls equipment and pipe work. And we'll see in some of the later videos the amount of controls and stuff that are installed in these, and you can get an idea of why these cost so much to install. So although the initial installation cost is fairly high, the actual operating cost is going to be much lower. And if you look at the units which are able to recover heat, this will actually be able to take heat from the indoor cassettes which are calling for cooling, and it will take that unwanted heat and move it to any cassette internally which is calling for heating. So this means that heat is not having to be generated within the building, and that means also that the compressor has had to do less work because it's not trying to reject any heat or less heat, and it's pushing that instead over to the indoor units which are cooling for heating. So as we saw slightly earlier, each zone can be individually controlled, and if one cassette breaks, then the rest of the system can continue to run unaffected. Now when installing these, you need to pay attention to the zoning that you're setting up, because if you've got two cassettes in one area and they're classed as different zones, then there could be potential that they're going to fight each other. So one is going to be calling for cooling, and the other cassette next to it is going to be calling for heating. So each of these will be fighting to service the load of the room. But we'll look at some of these technical details in later videos in this series on VRF units. Alright, that is it for this video. Thank you very much for watching. If you have any questions, please leave them in the comment section below, and don't forget to like, subscribe and share this video, and also check out our website, theengineeringmindset.com.